Okay, question 1B. Now, it's saying here, cross two plants from the first generation, the F1 generation. So if you remember from the previous question, all of the offspring, all of them, were capital C, little c. So when they say cross two of those plants, that's what we're going to do. We're going to use that from our question number 1. So those are our two plants. We don't need a legend. Now, I know we said step 1 is legend, but when you're using, let's say, questions 1A, 1B, 1C, and you're utilizing the same legend, no use doing the same thing over because you can just use the previous one. We will underline the parents. There's two plants from the F1 generation. Let's say what their genotypes are, capital C, little c, capital C, little c, and determine the ratio of genotypes and phenotypes of the offspring that result. Okay? So these new offspring are going to be considered F2 generations. Okay? So we're just taking two offspring from F1 and we're coming up with an F2. Okay? So our step 3 now is the Punnett square. So game of X's and O's. Cross out that first one. We don't know male or female, so just arbitrarily put one parent down the side, isolating those genotypes into gametes, and then the same thing for the other parent across the top. So I'm not going to do these for all of them, but I just want to make sure that you understand what we're doing with this Punnett square. We're taking the genotypes and isolating them into gametes. That would be the sperm. These would be found in the eggs. So half of her eggs would have a capital C, right, for inflated, and half of her other eggs would have the constricted gene for that particular trait. Okay, now step 4, fill in the Punnett square. We're simulating fertilization. We're bringing these guys together, and remember, you're always showing the dominant allele first. In this case, they're both dominant, capital C. And then within this box, get in that habit of doing that, we're going to put in the phenotype as well. So if you remember from the previous question, capital C is inflated. And of course, this would be homozygous dominant. Do the same thing for this. Again, showing the dominant allele first. So we're going to put the capital C first, small c, but that's also going to be inflated. Capital C, little c, inflated. And in this case, little c is going to be constricted. Now, if we take a look, and this is what they want you to do the phenotypic ratio. They say the genotypic ratio as well. I'm not going to get too hung up on that because when we do the Punnett square, we are giving you the ratio in there. What I really want is the phenotypic ratio. So if we count up how many are inflated, 3 are going to be inflated. If we wanted to do this in a ratio, which the question is asking, we need these little colons, and 1 is going to be constricted. We're just going to indicate what those are. That's inflated. That's constricted. We can't reduce this any further, so that's going to be our answer. And a 3-to-1 ratio, if you remember patterns, in our notes we talked about recognizing patterns, and that's going to make your work a little bit easier when it comes to problem solving down the road. But we know that if both parents in a monohybrid cross, so again, monohybrids are just one trait. In this case, the pea pod, is it inflated or is it constricted? That's just one trait. So when it's monohybrid, if both parents are heterozygous, which that's what we have in this example, we always know we're going to get a 3-to-1 ratio. 3 being dominant inflated, 1 in this case being constricted. Okay, any issues, give me an email, we can go over it. Thanks guys, bye.